Something isn't right here.
I lost all my money in the stock market. Life's not worth living anymore.
Wah! Don't jump. Things are gonna get better. I can prove it.
How?
With Precal. What is Precal? Merriam-Webster defines it as relating to or being a mathematical prerequisite for the study of calculus. Wikipedia defines it as an advanced form of secondary school algebra, a foundational mathematical discipline. We students like to refer to it as pre-awesomeness because of its many awesome applications to the everyday world. Example 1. The S&P average. The S&P 500 is an index of prices for the 500 largest cap stocks commonly traded on Wall Street. For a predictive graph, we will take the CAGR, which stands for Compound Annual Growth Rate, of the S&P average for the past 137 years. The CAGR is a geometric average that will tell us how much a dollar invested at the beginning of a given year will earn by the end of the year, as a percentage of that dollar. These CAGRs are then plotted with year 1871 as 0, year 1872 as 1, and so forth. When we connect the plotted points with lines, we detect a cosine graph. We can then take the mean of the S&P 500 data points in order to determine a midline. The mean here turned out to be 10.37. From our knowledge of stretching, shrinking, and shifting a plotted graph, we can conclude that a good formula for the S&P across years is y equals a plus b cosine of cx, where a equals 10.23605, b equals 20.5701, and c equals 2. Although the data from 2009 does not fit the line perfectly, we can estimate that it will reach 0 by 2011. Using only the knowledge gained from the statistics and graphing in precalculus, we have estimated future returns on the stock market, a simple version of how investment bankers and economists make a living. So it really is not worth jumping off a roof. Example 2. Space exploration. The spacecraft Voyager is on a mission to Jupiter. We need it to take a picture of Jupiter's 2 moons, Io and Europa, in the same frame. Back at NASA headquarters, the scientists are hard at work. They discover, through the use of their supercomputer, that at this moment the 2 moons are separated by 380,000 kilometers. The angle between Jupiter, Europa, and Io is 55 degrees, and that the angle between Europa and the perpendicular line we dropped from the line is 35 degrees. We want to know the distance that the camera needs to be from Io to take this picture. We know our lens range is 90 degrees, so we can draw an equal triangle that shares the same hypotenuse. Now we do our calculations. Sine equals opposite over hypotenuse, so sine of 35 degrees equals x over 380,000 kilometers. The sine of 35 degrees equals 0.573576, so we multiply 380,000 times that number to get our result of 217,959 kilometers.